Hello students, in previous class we discussed continuity of a function f of x for all real numbers. Now we are going to discuss continuity of a function f of x in a particular interval. Suppose we have a function f of x. When we are going to say the function f of x is continuous in an interval, open interval a comma b. So if I want to say the function f of x is continuous in between a comma b, I should say that f of x is continuous for all numbers between a comma b. So f of x should be continuous for all numbers between a comma b. Suppose the function is defined like this at a and b. So I have a function, I drawn its curve like this. At a it's not defined, at b also it's not defined, both are closed, both are open. See, in between a comma b the given function is continuous. How I can say? I can draw the graph of the function in between a comma b without lifting the chalk. So I can say the given function is continuous in between a comma b. So when I can say the given function is continuous in between closed a comma b, in closed interval a comma b. The same function you can consider like another way. Is a and the next value is b. At a I have a point, at b I have other point. I have defined the function like this. Now from a to b the given function is continuous. So if I want to say the given function is continuous from a to b, I should define the function like the left limit extending to b minus. The left limit of b minus of the function should be equal to f of b, and the right limit of the function at a plus should be equal to f of a, and the function should be continuous for all values between a and b. Then we can say the given function is continuous for open interval a comma b. So this is the example for the second one. So when I can say the given function is continuous at the interval a comma b, a is closed, b is open. So I can say the given function is continuous in this interval if for every points in between ab the given function is continuous, and f of x, the limit extending to a plus, is equal to f of a. Then we can say the given function is continuous in a closed, b open interval. So this is a continuity of a given function in particular interval. Suppose if you take a functions like f of, if a function is defined in between an interval closed ab, a function is defined in interval closed ab, and the function is broken into three different functions. The function is broken into three different functions like f of x is x as g of x, x as h of x, x as sum or of x for some particular cases. So if suppose I consider two real numbers which are lying in between ab, I consider c comma d, and I take c is smaller than d. Then the function is broken into three parts. The three parts are defined like this. It is a, b, so dot, this also dot, and it is c, and this one is d. Now I consider the first part g of x is defined in between ac. So the value of x lies in between a and c. Next, the value of x lies from c to d. If the value lies from between d to b, that's taken as or of x. So d less than x less than or equal to b. So the functions are broken in this way. Then how can I examine the given function is continuous or not? So to say the given function is continuous, we have to go for different cases. What are the cases? Case 1. So we must say the function is continuous at C. So we have to examine the given function is continuous at x is equal to C. So this, if I want to say the function is continuous at C, I have to find the function is continuous, means the left limit of C and right limit of C and x tending to C. So these three subcases will come in case 1. Next, case 2 and case 2. What is case 2? And D is lies in between AB, so it should be continuous at point D. So for x equal to D, I have to examine whether x tending to C plus, x tending to C minus, x tending to C, all limits are equal or not. After completion of this, I have to examine at point A as well as B. At point A, what I have to say, what I have to do. So at point A, limit x tending to A plus, so right limit of A, right limit of the given function at A should be equal to f of A. Should be equal to f of A. Next, at point B, so what I get, limit x tending to B minus, left limit of the given function at B should be equal to f of B. So I have to check these all conditions. Case 1, case 2, case 3, case 4. Again in case 1, case 2 we get 3 subcases. So by proving this all, by making this all are same, nothing but the function is continuous at C, the function is continuous at D, the function is left continuous at B, the function is right continuous at A. So if I am able to prove this all are exists, then I can say the function f of x is continuous in interval a comma b. Okay, let me do some problems. Domain of continuity. So what do you mean by domain of continuity? Domain of continuity is nothing but for what values the given function is continuous. See, the values we are considering from domain of the given function. Suppose a function f of x is defined in real numbers and the function is continuous for all x less than 2. Function is continuous for all x less than 2. So the domain of continuity is x less than 2. So this is the domain of the given function, and where the function is continuous is called domain of a continuity. So always domain of continuity is subset of domain of the given function. When we can say that the function is continuous, if the domain of the function is same as domain of continuity, then we can say the given function is continuous. Means for all its domain, for all values, for every value of its domain, the function is continuous, then the function is said to be continuous function. If I take an example, f of x is defined as x square minus 4 by x plus 2 for all x not equal to minus 2 and 0 for all x equal to minus 2. If x value minus 2, we get f of x value as 0. If x value not a minus 2, then we get the function as x square minus 4 by x plus 2. You check this, we have the numbers not minus 2 and minus 2. So the value of x is considered from real numbers. So what is the domain of the given function? Real number. The domain of the function is real number. Now whether the function is continuous for all the real numbers or not, we have to check. If the function is continuous for all the real numbers, then we can say the function is continuous. Otherwise, we say the function is discontinuous. See, the given function f of x defined for minus 2 and not minus 2. So we have only two wells. So we can take it as x tending to minus 2 and x equal to, extending to -2 and f of -2. Check it. Limit x tending to -2, right? X tending to -2 f of x. So which is equal to limit x tending to -2. The value of f of x is given as x square minus 4 by x plus 2. X square minus 4 by x plus 2. Then what we get? What we get? If I substitute -2 whole square 4, 4 minus 4 0, 0 by 0, indeterminate form. So we have to define the limit by taking its factors. So x square minus 4 can be factorized as x plus 2 into x minus 2 whole by x plus 2. We can cancel x plus 2 and x plus 2. We get x minus 2. Now you substitute the value -2 minus 2. I get minus 4. Now what about f of c? The value of f of c nothing but f of -2. The value of f of -2 is 0. So the function is discontinuous at x equal to -2. The function is discontinuous at x equal to -2. So we can say the function is discontinuous function. The function is discontinuous function. Let me go for another example. So one more example. If f of x is given as step x, f of x is given as step x, is step x. So what is the domain of step x? All real numbers. For all real numbers, the given function exists. Now consider one real number c which is belongs to all. So I consider this a real number c belongs to all. So now I have to examine the continuity of the function f of x at a particular real number c. So that depends in two cases. Case 1 for c not integer and c belongs to integers. If c is integer, then we have to consider one case 2, and if c is not an integer, what is going to happen? So if c is not an integer, suppose if I consider a number 1.5. So 1.5 is not an integer. Then what is the step 1.5 value? Nearest and smallest, which is 1. What is step 1.5? Nearest and smallest, which is 1. Now check it whether the function is continuous or not. Limit x tending to c f of c, nothing but f of x, the function, is equal to step c. So what is the step c value? If c is not an integer, we get, so what we get? 1.5. So we get step c. So based on the value, we will get the number. Now limit x tending to c, f of x we found. What is the value of f of c? The value of f of c is step c. The value of f of c is step c. You compare these two, both are equal. So if it is not an integer, then the function is continuous, because f of limit x tending to c, f of x is same as f of c. If it is integer, so if it is integer, let x is equal to some integer c. Now, so what happens if it is equal to c? We'll get again three subdivisions. What? For c plus, c minus, and at exactly c. So let me check. Limit x tending to c plus f of x is equal to, see, I have a number 1 plus. So 1 plus represents 1.0000 something. So which is nearest to 1 from the right side. Now what is the step value of this? Which is nothing but step c. So we get the value which is nothing but step c. So extending to c plus, limit extending to c plus f of x is equal to I get c. So what I get? C. Okay. Now limit extending to c minus f of x is equal to, limit extending to c minus f of x is equal to. So what I get? If it is 1 minus 0.9999 and so on. So what is the step value of this? Nearest and smallest, which is nothing but 0. So if it is 1 minus, I am getting 0. If it is c minus, what I get? Minus 1. Now what is the value of the function at exactly c? Extending to c, f of x is equal to step c. For integer, step c is nothing but c. Now what is the value of f of c? The value of f of c is equal to step c equal to c. Now check this all. C plus is c, c minus is c minus 1, f of c is c. So all the three values are different. So the function is discontinuous for x belongs to integer. For some number c, if it belongs to integer, then it is not continuous, and it is continuous for all not integers. So what I can say, the given function is continuous for all numbers which are real minus integers. So what is the domain of continuity? R minus I. So the domain of the given function is R. Domain of continuity is R minus I. So we can say step x is discontinuous function. It is not a continuous function. Find points of discontinuity, if any. If you have any points of discontinuity for this particular function, find those. Now, to examine the continuity of the given function, we should find the domain of the given function. So, domain of the given function, the function is defined for x greater than 0 as sin 3x by x plus cos x, and for x less than or equal to 0 as 4 minus 3x. So, the function is defined for all real numbers greater than 0, which are positives, and equal to 0 and less than 0, which are non-positive. So for that, what we can say, the domain is R. So if I want to examine its continuity, we have to take one real number which lies in its domain. Let C be the real number which lies in its domain. So now this examining the given function is continuous or not. That depends in three cases. What are those? C is greater than 0. If C is greater than 0, if C is less than 0, if C is equal to 0. So find those. Limit extending to C greater than 0, 0 plus f of x is equal to, what is the value of f of x for C greater than 0? The f of x is limit extending to 0 sin 3x by x plus cos x. Sin 3x by x plus cos x. Now limit extending to 0 sin 3x by x. So how we define? So here we have a 3x. So multiply and divide by 3. So I get 3 into sin 3x by 3x plus cos x. Now open the limit for both functions. What we get? 3 into limit extending to 0, limit extending to 0 sin 3x by 3x. So I have 3x. Now extending to 0, I can multiply by 3. So 3x tending to 0 plus limit extending to 0 cos x. So what I got? The value as 3 into 1 plus 1. I got as 4. So I got C greater than 0 as 4. Now I'll find out for C less than 0. So for C less than 0, limit extending to c less than 0. It's a negative number. C less than 0. So I take 0 minus 0 minus. So which is 4 minus 3x. 0 minus, the function is 4 minus 3x. To simplify it, 4 minus 3 into 0, which is equal to 1. So for c less than 0, I got 1. What about c equal to 0? For c equal to 0, limit c tending to 0, nothing but x tending to 0, f of x. What is f of x for x tending to 0? 4 minus 3x. Substitute x value 0 in this. 4 minus 3 into 0, which is nothing but equal to 1. So now you see, for c greater than 0, we got the limit as 4. For c 0 minus, we got the limit as 1. For c equal to 0, we got the limit as 1. So these all three are different. 4 is different from 1 and 1. So what I can say, the function is discontinuous at 0. The function is discontinuous at 0. So what is the point of discontinuity? Point of discontinuity is 0. So at 0, the given function is discontinuous. Next, take one more problem. F of x is defined as 2x for x less than 0, 0 for 0 less than or equal to x less than or equal to 1, 4x for x greater than 1. See, the function is divided into 3 subfunctions for 3 intervals. So I have to examine the continuity of the function at all these particular points. So what I have to do? For this, what is the domain of the given function? Domain x less than 0, all values which are less than 0, negative numbers, and x lying in between 0 and 1, not only between, from 0 and 1, so we have included 0 as well as 1, and more than 1, so I have all real numbers. So domain of the given function is all real numbers. So the domain of the given function is real number. Then to examine the continuity, we have to consider one real number which is belongs to its domain. Let me consider c belongs to R. C belongs to R. If c is less than 0, if c is less than 0, so what we can expect? Limit extending to c minus. If for c less than 0, limit extending to c. What is the value of limit extending to c? F of x, limit extending to c. F of x is defined as 2x, which is equal to 2c. Limit extending to c, extending to c, 2x is 2c. And what is f of c? For x less than 0, for x less than 0, what is f of c? 2 into c, which is equal to 2c. Both are equal. So the given function is continuous for c less than 0. For c less than 0, the given function is continuous. So case 1 got over. Next, I am going to case 2. What is case 2? At c is equal to 0. So if I take c is equal to 0, there 3 subconditions will come. That is 0 minus, 0 plus, and exactly at 0. So if I take 0 minus, then what is my function? Limit extending to 0 minus f of x. What is limit extending to 0 minus f of x? the function for 0 minus, which is slightly less than 0, the function is defined as 2x. So I get the function as 2x, I get 0. Now next, limit extending to 0 plus f of x. For limit extending to 0 plus f of x, 0 plus, so which is lying in between 0 and 1, I get 0. So what about the limit extending to 0 exactly? Extending to 0 exactly, the given function value is nothing but equal to 0. The value of the given function is 0. Exactly 0, they given as 0. So the given function is continuous at c is equal to 0 also. Continuous, and here also continuous. Now what we have to do? We have to check for case 3. So case 3, what is case 3? The next point, what is the next point? 1. So for c is equal to 1. If I take c is equal to 1, again we get 3 cases for 1 plus 1 minus and exactly equal to 1. So limit extending to 1 plus f of x is equal to 1 plus, which is 4x. So limit extending to 1 plus, which is 4x. 4 into 1, I get 4. Next, limit extending to 1 minus f of x. What is 1 minus f of x? 1 minus is greater than 1, slightly less than 1, which is nothing but 0. So we get 0. Limit extending to 1 exactly, which is also equal to 0. Now what I can say, the given function is discontinuous at 1. The given function is discontinuous at 1. Now x greater than 1. Find the function for x greater than 1, which is case 4. Which is case 4. For case 4, x greater than 1, the value of c greater than 1. Now limit extending to c f of x. So c greater than 1, what is the function? Limit extending to c 4x, which is equal to 4c. What is the value of f of c for x greater than 1? 4c. So the given function is continuous at c is greater than 1. So for all these cases, the function is discontinuous. The function is discontinuous only at one point, which is nothing but c equal to 1. The function is discontinuous at c is equal to 1. Function, examine the function is continuous or not. So before going to say the function is continuous or not, we have to define its domain. What is the domain of the given function? X plus 5 not equal to 0, x not equal to minus 5. X not equal to minus 5. So the domain of the given function is r minus 5. R minus 5. Now we see the given function is continuous or not in its particular domain. So now if I want to say the given function is continuous, I have to take a particular number which lies in its domain. So let's see a number c which belongs to its domain. So I consider a number c which belongs to its domain. Now what is f of c? F of c is equal to c square minus 25 by c plus 5, where c not equal to minus 5. So we are defining this particular thing for c not equal to minus 5. Now what I get? C plus 5 into c minus 5 by c plus 5. So I get c minus 5. Now limit extending to c minus f of x. So what is limit extending to c minus f of x? So limit extending to c minus f of x, the function is same for all numbers except minus pi. At minus pi, the function is not existing. The function does not exist at minus pi. So at that particular case, c minus acts as c plus acts as limit extending to c. So what we have learned in the previous class. So if I find these all things, which are nothing but limit extending to c, x square minus 25 by x minus 5. X square minus 25 can be written as x plus 5 into x minus 5 by x minus 5. X minus 5 cancel. Now extending to c, which is nothing but c plus 5. Here f of c is equal to limit extending to c f of x. So the function is continuous for all its domain. For its domain except minus 5, the function is continuous.